Measuring the Rising Seas, presented by Science at NASA. Earth is enveloped by a vast ocean that covers about 71% of our planet. Even tiny changes in this body of water can add up to enormous effects on climate and weather. The Jason 3 satellite, launched on January 17, 2016, will allow scientists to continue a 23-year record aimed at studying Earth's ocean to better understand and forecast our climate, months and years into the future. Jason 3 project scientist Josh Willis of NASA's Jet Propulsion Laboratory in Pasadena, California, says Jason 3 will measure the rising oceans and changing climate for the next 5 years. Jason 3 is the latest in a series of satellites that accurately measure the height of the ocean surface dating back to the launch of Topex Poseidon in 1992. Next came Jason 1, launched in 2001, and then Jason 2, launched in 2008. Jason 3 will be joining Jason 2 in orbit. For Jason 2 and Jason 3, the National Oceanic and Atmospheric Administration, or NOAA, and the European Organization for the Exploration of Meteorological Satellites, or EUMETSAT, joined an international partnership with NASA and the French space agency CNES. Willis adds that from one mission to the next, we want to overlap our Jason data and stitch it together to give us a consistent story of how our climate is warming and our oceans are changing. Global sea level rise measured by these satellites is one of the clearest indicators of how humans are changing the climate. This line of data collecting ancestors have all measured sea surface height using a radar altimeter, an instrument similar to weather radars here on Earth. Here's how it works. The satellite emits a pulse of radar waves that travel down toward Earth, bounce off the surface of the water, and return toward space. Once the satellite detects the return signal, the altimeter calculates the round-trip travel time. The longer the round trip, the lower the waters are below. The height of the water also tells us about how warm the waters may be between the surface and the bottom, because warm water expands and causes a rise in sea surface height. The opposite is true for colder waters. Ocean temperatures are making big news right now as a massive band of warm water builds up and moves from west to east across the equatorial Pacific Ocean. This phenomenon, called El Niño, causes abnormal weather patterns around the globe. Ripple effects could include rainy and cooler weather in the southern United States and a chance to put a dent in California's current drought. A reverse of the El Niño phenomena, called La Niña, is associated with the drought in the southwest. Willis says, El Niño is here. We have launched Jason 3 right into the biggest El Niño since the turn of the millennium, and the Jason data will allow us to see whether it goes quietly or slingshots the Pacific into a huge La Niña, like the last big one in 1998. The Topex Poseidon and Jason satellites have a history of measuring climate change and monitoring El Niño. Soon, Jason 3 could be making history of its own. For updates from the Pacific and around the world, stay tuned to science.nasa.gov.